Okay, so now that you know what a normal curve is, I'm sure you're asking the question, well, how would you find probability if it didn't land on a nice standard deviation? Sure, you're asking that, right? Well, let's go back to that tire example. If you remember the tire example, your tires last around 30,000 miles with a standard deviation of 5,000 miles. And we sketched that normal curve out. We put 30,000 here, and we counted by fives. All right, it's 3 standard deviations both ways, which number one takes some time to do, right? We don't want to be doing this all the time. Mathematicians are lazy, and there's going to be an easier way that I'm going to show you today. But the other question is, okay, we know that 68% of tires fall between 25 and 35,000 miles. But what if I wanted something like a tire that's 27,000, let's say would be right here. What if I want to know the probability that a tire lasts between 27,000 and 33,000? Okay. And some students say, well, you would just divide that in half, 34 in half. Well, if you notice a normal curve, this area you can't divide in half. This area on the left is going to be larger than the area on the right. This isn't a nice perfect rectangle. So you just can't take an area of a section and divide it in half. You can't do that. It's not the same. Okay. So when we have questions that ask for probability or a certain amount, and it doesn't land on a nice standard deviation, we have what we call the z-score. We can convert any raw score, which like 27,000 would be considered a raw score. 33,000 is considered a raw score. Okay, that's when I say raw score, that's what I mean. I mean a data value. We can convert any of these data values into a z-score. So the thing with z-scores is that the mean, right, this 30,000 raw score is a mean. The z-score for the mean is always 0, okay? And then my one standard deviation, 35,000, that's going to have a z-score of +1 because it's one standard deviation from the mean. 40,000 is going to have a z-score of 2. And 45,000 is going to have a z-score of 3 because it's 3 standard deviations from the mean. So then going this way, 25,000 raw score is going to have a -1 z-score because it's one standard deviation left of the mean. 20,000 is going to have a -2 z-score, and 15,000 is going to have a -3 z-score. Okay, so these are the raw scores with the corresponding z-scores. So what's going to happen to numbers like 27,000, we can kind of look at this and think, okay, 27,000 is going to have a z-score of -0.6, something like that. It's going to fall somewhere in between 0 and -1. 33,000, the z-score for that is going to be probably somewhere about 0.54. I don't know, right? So I have a formula for you to figure that out. We're not doing that quite yet today. 5-1 lesson just focuses on z-scores and using the table in the back of your book to find the probability with those z-scores. After we practice that, then we go on to 5-2, where you'll take raw scores into z-scores and then find probability. So each section in this book kind of builds, okay? So if I see a normal curve, okay, this is what a normal curve with z-scores look like. And another thing to note on a normal curve is that if I have a normal curve that looks like this, compared to maybe a normal curve that looks like this, okay? See how this normal curve is more spread out than this one? I can tell by looking at these two normal curves that this standard deviation is larger than this standard deviation. The bigger your standard deviation is, the wider your normal curve is. If I have a really small standard deviation, then maybe my normal curve would be even skinnier, like that. It'd be even narrower, okay? So that's something to know. We're also going to look at the rules for normal curves. As part of your assignment today in your book, you'll read the rules of a normal curve. Okay, so let's get into how do I find an area of probability that doesn't land on a nice standard deviation. I just can't add 34 plus 34. What if it's somewhere in between, right? If I went from here to here and I want that area, how do I find that? Okay, so in your book, you have a table on page A, is it A16? Hold on. In the back of your book, yep, A16. A16 is the table you're going to be using a lot in this chapter. So mark it maybe with a Post-it or something, because you're going to keep turning to this. The biggest thing to notice on this table on A16 is that this only does probability of area to the left. So if I want the probability, remember that tire question of a tire lasting less than 25,000 miles, right? Okay, your book only does area to the left, only something that's less than. Okay, so let's practice that. Okay, so I have a z-score of negative 1.93. What's the probability of it being less than negative 1.93? So you look in your book, and you should notice that the left side's negatives, the right side's positives. So I'm looking on the left side. And the first column here is a z-score, but it only goes to the tenths, that you'd have to go up here to find the hundredths. So negative 1.93, I would go negative 1.9, which is here, and then negative 1.93 would be all the way over here. So it'd be 0.0268%. Okay, so I go down negative 1.9 over to the 0.03, and that is 0.0268. And it should make sense when you're done. Does this look like 2.68%? Yeah, if this whole normal curve is 100%, this looks like 2.68% of that. Okay, let's try another one. Maybe. Okay, so this one is 1.99. Now, just looking at the picture, this is going to be a high percent, because I know the middle, 0, that's 50 and 50. It separates it into 50-50. So I know this is 50, and then I'm doing almost 50% more. So I should, just by looking at it, know this is going to be a high percent. So I'm looking up 1.99, because it's area to the left of that. So 1.9, it's going to be on the right side, because these are positive z-scores. So I find 1.9. And then I need the hundredths to be 9. So I go all the way over to the very last column, 1.99, 0.9767. Okay. So this probability, this area, is 97.67% of the normal curve. Okay, so when you're doing area to the left, you just look up the number. Okay, so now I bet you're asking, well, what if it's something that's greater than? What if I want the probability that it's going to be more than 33,000 miles on my tires? So then we do it a little bit differently. So if I want area to the right, and I know this whole thing is 100%, think of it this way. If I gave you a rectangle, right, and I told you that this area of the rectangle is 15 inches squared, and the whole rectangle, the whole thing, is 20 inches squared, what's that area? If I know this is 15 and this whole area is 20, what's x? We should know that it's 5 inches, right? Because then 15 plus 5 equals the total area 20. Okay, what am I getting at here? I'm getting at this whole normal curve is 100%. So if I know this percent, then I find this percent, just like I did here. Okay, so let's look up 1.11. 1.11 is going to give us the area to the left. Okay, so we got to do that first. 1.11, and you should get 0.8665. So I know this is 0.8665, but I don't want that. I want the yellow region. So if I know this whole thing equals 1, 100%, 1, I can take 1 minus that and get this yellow region, which would be what? 1 minus 0.8665, 0.1335. And that should make sense. This shaded region should look about 13.3% of the normal curve. Okay, so you can do it by the complement. Let's try another one. I have another one. Okay. So negative 1.16. I want the area to the right. My book doesn't do area to the right, but it does area to the left. So if I look up negative 1.16, I get 0.1230. Okay, but I want this area. So I know this whole thing is 100%. So to get this area, I can do 1 minus that and get what? So 1 minus 0.1230 is 0.877. Okay. All right, so there is another shortcut. We know that a normal curve is symmetrical. So another way you can do this is you can look up the opposite number to get area to the right. Because if I had this, right, and if I did the opposite number, 1.16, then this shaded region equals this shaded region because they're symmetrical. Now look up 1.16, the positive, look up the opposite number, 1.16. What do you get? So if you look up 1.16, we get 0.877. So it's a little bit faster to get it. You can still do it this way by the complement, that's fine. But to get area to the right, you can also look up the opposite z-score. It's a little bit faster. Okay, so then, of course, you're wondering, well, what if it's area in between, right? We saw that on our homework yesterday, is that it wasn't just a less than or a greater than, it was between two things. Okay, so if I want area in between, if I tell you, let's do a rectangle again. If I tell you that this whole rectangle is 30 inches squared, right? The whole rectangle is 30 inches squared. And I tell you that, if I tell you that this blue rectangle has an area of 20 inches squared, and this green rectangle has an area of 8 inches squared, how would I find this black area? Okay, so if I know the blue, the whole thing here, this blue thing is 20, and the green is 8, how would I figure out the black? Well, I would know that 20, this whole blue, 20, minus the 8, that's not shaded, would then equal the black, right? Because the black plus the green is going to equal 20. So if I take 20 minus 8, what's the area of the black then? It should be 12 inches squared. And I could say, okay, 12 plus 8 is 20. Okay, so what you're doing is this. You're going to look up 2.34. 2.34 is going to give you the area of this whole area to the left, right? The whole area to the left, if you look up 2.34. I don't want the whole area to the left. I want to stop here. So then I can look up 0, and 0 will give me this area. So how would I find the yellow area? Well, to find the yellow area, I would take the blue area minus the red area, and that leftover is going to give me the yellow. Okay. All right, so look up 2.34. So look up 2.34 and I get 0.9904. Look up 0, and you shouldn't have to look up, you should know it's 50%. Okay, so I know that this whole thing is 90.9904, and then this is 0.5. So I'm going to take the whole area, 0.9904, subtract the area I don't want, this white area, which is 0.5, and that'll give me this yellow right here, which would be 0.4, not 5. And that should make sense. This yellow area is just less than half, okay? So when you do an area in between, you look up the bigger z-score percent, then you look up the smaller z-score percent and subtract them. Let's try another one. Okay, so I'm going to look up the bigger z-score percent, 1.68. So 1.68 is 0.9535. Look up the smaller z-score percent, negative 1.37, negative 1.37, 0.0853. And I take the larger minus the smaller. You can't really mix this around because then you get a negative probability. We can't have negative probabilities. And that equals what? 0.9535 minus 0.0853. 0.8682. And that looks about right, right? That looks about 86% of my shaded area there. Okay. Let's try a couple more. Okay, so area in between. What's my rule for area in between? Look up the larger z-score probability, 1.8, so 0.9641. Look up the smaller z-score probability, and I'm going to take the larger minus the smaller, and there's my answer. Okay, let's try one more. So area in between, right? Area in between, let's do this one. I look up the larger z-score. Yep, they're both negatives, but you still have a larger z-score. So negative 0.83, negative 0.83, 0.2033. Look up the smaller z-score, negative 2.48, negative 2.48, 0.0066, and subtract the bigger minus the smaller, so 0.2033 minus 0.0066. 0.1967. Okay, so that's how you do area in between. One more thing you might see is if you have both area to the left, area to the right. Okay, we've done area to the left and we've done area to the right. So here's a good review on what we just did. How do I find area to the left? You just look up the number. Okay, so let's write some notes now that we've seen everything. When I want to do area to the left, you just look up the number. Okay, so negative 0.301. I'm just going to look that up. Negative 0.301. 0.0013. How do I find area to the right? You can do the 1 minus thing, or you can look up the opposite z-score. So area to the right, look up opposite number. I should say number, right? Make it easier. Look up opposite number. So instead of 2.43, I'm going to look up negative 2.43, and I get 0.0075. Okay, now I want the probability it lands in one of those areas. So this area, or means add. So 0.0013 plus 0.0075. So 0.0088. Okay, so my last rule, since we're writing these rules right now, is area in between. Okay, when you're doing area in between, you look up the larger number and subtract it from your look up the smaller number. Right? So you look up the large number, find that probability, and subtract it. You look up the smaller number, and then you would subtract. Okay. The biggest mistake students make is when they're doing area in between, they try to do this, area to the right. Don't get those mixed up. There's specific rules. You're either doing all the area to the left, all the area to the right, or area in between. Okay, you only have those three. Don't try to combine these two. Okay. So let's just do a couple without a picture. and we're not going to do all of these. I'm just going to pick some here. Let's just do 14. Okay. If in doubt, sketch it out, right? That's kind of the big thing in mathematics. If you have a hard time visioning that, sketch it out. But your rule for area in between is what? Look up the bigger number first, then you look up the smaller number, and then subtract them. That's how you do area in between, right? So what I'm doing, if I'm confused and I want to sketch this out, I can put in 1.9, I can put in 1.23, and I can see it's like this, area in between. So I'm going to look up 1.9, and 1.9 is 0.9713, and then I'm going to look up 1.23, right? Not the opposite, even though it's to the right, it's not all the way to the right. So you're still looking up that exact z-score, 1.23, and it's 0.8907. And then I subtract the bigger minus the smaller, okay? So area in between, you just look up those numbers, don't change anything, just look up the numbers and then subtract them. 0.9713 minus 0.8907, 0.0806. Okay, so again, that's how you do area in between. Let's do one to the left. So let's do 20. Okay, so what's my rule to find area to the left? This is the easy one. When I'm doing area to the left, right, that means all the way to the left, right? There is no in between, it's just all the way to the left. I can just look up that number. It's that simple, area, because that's what my book does. It does area to the left. So I can just look up 1.31 and get 0.9049. Okay. Let's do an area to the right. So 22. So what's my rule of area to the right? Look up the opposite z-score. Now, it's not between, it's just to the right. So if I have negative 1.92 and I want everything to the right, this is when I flip the z-score. So now I can look up a positive 1.92, and if I look up a positive 1.92, I get 0.9726. Okay, and then let's do one more with the tails. So to the right of 1.92, to the left of that, I'm not doing area in between here. What I'm doing is some tails. I got 1.92, that area, negative 0.44 in that area, and I'm going to add them together. Okay, so to find this area first, I can see that this is area to the left. So I look up negative 0.44, right? When you're doing area to the left, you just look it up. Negative 0.44 is 0.33. Area to the right, I'm going to look up negative 1.92, because whenever I have area to the right all the way, I can look up the opposite. It's a little bit faster. Negative 1.92, negative 1.92, 0.0274, and then I can add those two together. So I would get 4753. There we go. Okay, so your homework for 5-1 here is you are going to read page 234. This is going to tell you all of your normal curve rules. And then you are going to do 11 through 16 all. And then you're going to practice finding some z-scores, so 17 through 35 odd. And I gave you odd on purpose so you can look up those answers to double check yourself, because this whole chapter is going to base off of what you learned in this section, so it's really important. Okay, and then you're going to do 39 and 40. And you need to know anything unusual. Anything unusual is less than 5%, or, right, since we're doing normal curve now, anything more than 2 standard deviations from the mean. So if anything's more than 2 standard deviations from the mean, that means any z-score greater than 2 and any z-score less than -2, right? If you got a z-score and it's greater than 2 or less than -2, anything more than 2 standard deviations, right? Or if you sketch out a normal curve and put your mean in and count 2 standard deviations, get a number, count 2 standard deviations, get a number, anything bigger than this number or less than that number is considered unusual. Anything more than 2 standard deviations. Okay.